Very important. You can't imagine how important is it. And then let us say that the sound, you can steer the sound. Like the sound is at an angle because you have a sector image. You don't have a linear image. You have a sector image. Just hear from me, guys. And let us say that you are hitting a structure like a bone of a fetus. Is the speed inside the bone different from the speed outside the bone? Yes, the bone is very stiff, so the speed is higher. So the sound beam, guys, that is coming and hitting the bone, because the speed of the sound in the bone is higher, it will deviate outward like that. You agree with me? Okay. The problem, guys, that I might have another bone here. This is another bone. Will I see it? Yes, because the sound when it bends, it comes to the other bone. But my computer, guys, my computer does not assume by any means that the sound might bend. Like this is not in the calculations of my computer. So my computer, instead of putting this bone, which it sees when the sound bends like that, my computer will assume that the location of the bone is there. So guys, this is the real, this is not the real, this is the real bone location, but this is the location that you're going to see on the screen. It makes sense to you guys? Because my computer does not assume that the sound bent. But when the sound really bent, it sees the bone. So the bone is here. But the computer thinks that the sound is not bent, thinks that the sound is straight. So he puts the bone here as if the sound is straight. It makes sense, guys? Yeah. What happens, guys? The bone is supposed to be here, and you see it there. What happens? There is a misplacement. Side to side misplacement. You agree with me that? Yeah. Side to side misplacement, another word for side to side misplacement is?
Registration.
Lateral. Side to side means lateral. When you have something on the right and you see it on the left, this is called lateral. Side to side means lateral. Misplacement. Another word for misplacement is misregistration. So guys, let us repeat that again because it's very important. When you have refraction, how you see it while you are doing ultrasound? You see it twice. You see it in the form of an edge, shadow. You see it in the form of lateral misplacement or lateral misregistration. Make sense, guys? This is the two conditions in which you're going to see refraction, real refraction while you are scanning. Ask me, Patrick.
No, I'm good.
Okay. I know that this is confusing because you will let me repeat again. What is the meaning of refraction? Refraction means that the sound bends. Why it bends? For two reasons, which are change in the speed and hitting at an angle. What will be the consequences? While I'm scanning, I will see edges, shadow edge, edge shadow. If for any curved structure, like you are scanning the head of the fetus, the skull, and the edges of the skull, you're going to find edges of shadow. If you are scanning the TCA, you find edges of shadow. I showed to you, it's easy to see. You are good with that? You are good with that?
Yes.
The second thing that you're going to see that an object is supposed to be here, you see it to its right or to its left. There is lateral misplacement. Lateral means side to side misplacement. This is bad about refraction. Why? Because when the sound bends, it sees something. But my computer does not think that the sound bent. He will put it here instead of here, as if the sound does not bend. You got that logic?
Mm-hmm.
My computer does not put in its calculation that the sound might bend. When my computer builds the image, he assumes that the sound does not bend, does not refract. So when refraction happens and something is seen, my computer thinks that the sound is not bent, so he will put it as if the sound is straight. He will put it here.
Mm-hmm.
Like in my imagination, guys, in my imagination, that Jane Lauren will be always here, but she decided to sit there. I'm a blind person. I'm a blind person. Like the computer is a blind person. He has calculations. He doesn't really see. I'm a blind person, so I'm assuming all the time that she is here. So I will deal with that as it is. Okay. So if on a screen I put her image, she's here actually, but I will put it there. This is what happens. Okay. Our computer, guys, is just building the image on calculation, neither more nor less. So guys, I'm good with this part. Okay, you have questions?
Should we write the lateral misplacement down? Or
Yes, write it down. This is number 2. Number 1 is the H shadow. Number 2 is the lateral misplacement. So this is guys the location seen on screen. This is the location seen on, and this is not real, guys. This is not real. Despite seeing on the screen like that, this is not real. And this is the actual location. Okay. Let me talk about something. Okay, this part you already finished, all of you, this part. So let us clear this one. And let me think about attenuation again. Attenuation means that the sound is weakening of the sound. Why weakening happen, guys, as I told you before? Due to absorption, which is conversion into heat. What else?
Scatter. Reflection.
Reflection. Guys, this is very important. Attenuation means that the sound gets weaker. As the sound travels, it gets weaker. Weakening as sound travels. As the sound travels, it gets weaker. Why? Because as it travels, it is converted into heat. As it travels, some of it will be reflected back, so the remaining will be weaker. It makes sense? And reflection, as I told you before, is 2 types, which are
Scattering.
specular and
Oh, non-specular.
non-specular. Okay, let us talk about this weakening, guys. Weakening will happen anyway. You agree with me in that? Weakening will happen any way as sound travels. So as sound travels, weakening will happen anyway. Weakening too early, too young. So weakening will happen anyway as the sound travels. But take care of what I'm going to say, guys, in moderate amounts. So as the sound travels, it gets weaker. As the sound travels, it gets weaker. This is why, guys, the top of image, this is the closer to skin. The top of the image is, we call it the near field also. Is brighter than the bottom of the image. This is deep away from the skin. We also call that the far field. So guys, if I'm drawing a screen for you guys, this is the screen. The top of the screen, guys, is the skin, where the transducer touches the skin. And this is, guys, the near field. And this is the far field. The near field is brighter. The far field is dark. How we compensate for the darkness of the far field? What do we do, guys?
TGC?
Here we go. Guys, you agree with Sean in what he says?
Amplitude.
Okay. How, like in the near field, it is brighter because the sound is still strong. But as the sound travels, it gets weaker, so the image becomes darker. In the near field, it is brighter. In the far field, it is darker. This is without the adjustment of the TGC. So what is the purpose of using the TGCs? To compensate for the weakening, for the attenuation that happens as the sound travels. It makes sense, guys? The TGCs, guys, are amplification. I amplify the coming back sound. But I will amplify the coming back sound in the far field more than the near field, so they become equilibrium. It makes sense? So I am in need of, there is an in need of adjustment of TGCs, which are also called time gain compensation, which are also called DGCs, depth gain compensation, which is also called, guys, just this word, compensation. When I say compensation, as if I said TGCs. What does it do, guys? There is a need to adjust the TGCs to, look at this word, guys. Compensate. There is a question that you will read with a lot of words, but you read this word in the middle. Mostly you think about TGC. Mostly the answer is TGC. What does it do? To compensate for attenuation. That happens as sound travels. To what? To do what? This is the core of the answer. Guys, this is the core of the answer again. In the question coming about TGC, you're going to read this word, compensate. What does TGC do? Compensate. You may not understand the whole question, but you read this word. Think about TGC. So I got it. As the sound travels, it gets weaker. As the sound travels, it gets weaker. Let me talk a little bit about that. Let us say that this is the string, and the sound is coming down like that. And when the sound is coming down, there was a big storm. Guys, can you just give me a minute, because this is very confusing for many of you. Like in my previous classes, if they don't give you concentration, you're gonna get confused with this one. Give me attention. Okay, so guys, let us say that I'm scanning. This is the skin. At the top of the screen, you know that it is the skin. When you are watching a screen, the top of the image is the skin, where the transducer touches the skin. And as we go down, we get deeper. I'm assuming that while I'm scanning, guys, down here at the kidney area, I found a stone. Will the attenuation happen? Yes. Like attenuation happens as a sound travels. But in the stone, attenuation will be more than the average. Like attenuation will happen anyway. As the sound travels, it gets weaker. But because I made a tone, the sound will be really, really weaker. Why? Because attenuation is caused by absorption and by, here I'm talking about reflection. Most of the sound, guys, will be reflected back. Most of the sound will be reflected back. The stone will not allow the sound to pass through it. It's a stone full of calcium. So the sound will be excessively weakened. Attenuation will be more than the actual excessive weakening, not the regular weakening. Because of a lot of there is a lot of reflection, so the sound is excessively weakened. Actually, the stone can be called, guys, strong attenuator. All of these are questions. Each thing I'm writing is a question. The stone is considered as a strong attenuator, a strong weakener, strong object that causes weakening of the sound. What will happen behind that stone? The sound will not pass through it. What are you going to have here, guys?
Shadow.
A real shadow. Not the edge shadow. This is the regular shadow. Shadow behind the strong attenuator. Take care, guys, of what I'm going to say. Shadow starts with the letter,
Yes.
and strong attenuator start with the letter. Yes. I care about that because you're going to get confused later. I'm going to give you the opposite situation right now exactly. So, if you have attenuation more than average, due to a stone like that, the end will be a shadow. Where it will be the shadow? Behind. Behind means underneath. Another word for underneath and behind is distal. All of these are words that are used. So what will happen distal to the strong attenuator? Look at the wording in the test. What will happen distal to the beyond? I can put the word beyond. What will happen distal to the strong attenuator? I will have a
Shadow.
Okay, let me give you the opposite scenario. I am now having a screen. Inside the screen, guys, I have a vessel like the CCA. Inside the CCA there is blood, a fluid. Blood, guys, will not attenuate the sound at all. Anyway, I told you guys, as we travel, attenuation will happen. But in the blood area, there is no attenuation. So what will happen? The opposite. If you don't do the regular attenuation here, the area beyond it, guys, is, this area is brighter. This area is brighter than the surrounding areas. This area is brighter than the surrounding area. We give it a name opposite to shadow. We call it enhancement. A word, you have to know it. I consider the blood vessel, guys. Here I say this is a strong attenuator. Here I will say this is a weak attenuator. So enhancement happens the same. I will write the same word. Behind, underneath, distant, beyond, the weak attenuator. I A good strong attenuator is a stone or any calcified, anything that is calcified. Calcified means full of calcium, like a bone. A weak attenuator, a good, is anything that contains a fluid. What contains a fluid? Blood, cyst, or a cyst, guys. Like you have a cyst. So blood, or we can do it. A good is cyst or blood vessel. So guys, this is attenuation more than average. Here, attenuation is less than average. So guys, we have two scenarios for attenuation. Attenuation will happen anyway. As I travel, I get weak. Sometimes, if I face a stone, I will be excessively weakened because the stone is a strong attenuator. Behind the stone, I will have shadow. Sometimes, guys, like while I'm traveling, I was spoiled. I was in a swimming pool, so I was not attenuated at all. Swimming pool like a blood vessel, like a cyst. So behind it, I have a bright area which is called enhancement. So guys, attenuation has to be average. Attenuation has to be average. If it is lower than average, I will have enhancement. If it is more than average, I will have shadow. Okay, so shadow and enhancement are because of a non-average attenuation, either excessive or less than average attenuation. Make sense, guys, what I'm saying? Okay, let us say it again. Guys, let us say that I am driving a car. Okay, then the known gas that will be consumed by the car is 2 gallons per mile. This will happen anyway. Okay. I'm assuming, guys, that I have a better car. It doesn't consume 2 gallons. It consumes 1 gallon per mile. So, guys, I will have more gasoline in my car for longer period of time because it consumes. So I can drive more. The image will be brighter. Anyway, I will use a gasoline. Anyway, as I travel, I will consume some gasoline. But here, I am lucky. I will consume less gasoline than I should. So I will have at the end what we call enhancement. I have more gasoline for more driving. The image will be brighter in the far field here. Okay, guys, I am the opposite. I use an old car that is using 4 gallons per mile. I will finish all of my gasoline at a shorter distance than the average people. Most of the people are 2 miles per gallon. But I am the bad one who is driving with 4 miles per gallon. So all of them will speed up. In comparison with them, I will be behind. When I use 1 mile per gallon, in comparison with them, I am in the front. It makes sense, guys? I am not in the average. I'm supposed to be in the average with the rest. So if I am more than the average, I will have enhancement. If I am less than the average, I will have shadow. But anyway, as we travel, we get weaker. Anyway, as I drive the car, I will lose gasoline. But in some cases, I will lose more than I should, and in some cases, I will lose less than I should. So I will not be with the crowd. I will be different. The problem is in that difference, that you're supposed to see the image all in 1 degree of brightness. Sometimes you see a part brighter than the rest, or a part darker than the rest. When you see a part darker than the rest, this is called shadow. When you see a part brighter than the rest, we call it enhancement. Why enhancement happens? Because of a weak attenuator. I'm going to show you that today. Why shadow happens? Because of a strong attenuator. Don't forget, S comes with shadow. Strong attenuator will cause a shadow. Where will be the shadow? Distal to the strong attenuator, behind the strong attenuator, underneath the strong attenuator. I'm using this language. Beyond the strong attenuator. The shadow will be behind it. The bright area also will be behind the weak attenuator, which is a blood vessel or a cyst. Make sense, guys, this part?
Yes.
This is very important. Okay, so we see that on ultrasound. I'm gonna show you today, guys, the edge shadow. I'm gonna show you the enhancement. Okay, right. I give you that one. Okay. I will not do that now.